My name is Prapti Sangri, and today I will give you a walkthrough of the Northeastern Aladdin, a document based AI assistant. This project was inspired by BlackRock's Aladdin, which manages more than 25 trillions in global assets. Aladdin is not just a software. It is the core operating system of modern finance, blending risk analytics, portfolio optimization, trading, and compliance into one seamless environment. This version that I have created is not meant to compete with Aladdin. Instead, it is an educational simulation, a tool designed to show how prompt engineering, curated data, and validation frameworks can replicate key aspects of Aladdin in an academic context. My assistant acts as a quant mentor. It does not just produce numbers, it contextualizes them with psychology, with social equity, with mathematics, and with climate and ESG. It is designed to teach and to warn, not to simply optimize. Let me begin by explaining how the system is structured. The repository is organized into a set of folders and scripts that define assistant's life cycle. Inside the repo, you are able to see the response folder that contains the raw outputs from the assistant. Every single test case is numbered from T01 to T60 and FNL 01 to FNL 40, and it is stored in the format of .txt file. If you want to see how the assistant actually answered to the prompt, you can open this folder. The artifacts folder has captured all the failed test cases. Whenever the validation fails, whether due to the missing disclaimers, schema errors, or incorrect formatting, the responses are saved here. This is called debugging archive. The runs folder is the control room. It contains a specialized AI assistant.json file which defines all the 100 test cases. This is where each test ID, input prompt, and expected schema is written down. And specialized AI summary is the report card. It is the most recent run. It shows 79 tests passing and 21 failing. Then we have the validators. Validate.py is a lightweight validator for single responses. Validatefiles.py is heavy-duty script. It scans all the responses, enforces schema and compliance rules, writes the CSV summary, and automatically stores failing cases into the artifacts folder. And finally, we have the README file, which is the front door to the project. It explains the assistant's design, its persona, its function, and how to run validation. Together, this repository is reproductive, transparent, and handover ready. Now, let me take you to the one of the most instructive examples, the failed test case 59. This is the real output that is generated by the assistant that did not pass the validation, and here it is given in the full. So here what's the response was trying to do. The test case involved a data disambiguation challenge. Two different S&P 500 files, one called SP500.csv and one called S&P 500 historical data CSV. The assistant correctly identified that one file contained a longer historical series with observation dates, while the other contained recent daily price movements with percentage changes. Then it proposed a file conflict resolution strategy. First, use the first file for a long trend analysis and second for the short-term volatility analysis. That's a sophisticated approach. It went even further, producing a sample allocation of 40% technology, 30% in healthcare, 20% bonds, and 10% in international. Alongside that allocation, it calculated a portfolio variance of 0.0298, an expected return of 6.8%, and a Sharpe ratio of 1.06, and 95% value at risk of negative 8.3%. The assistant also included a bias flag, pointing that using two different S&P files could introduce inconsistencies if not aligned to correctly. That shows critical awareness. Finally, it produced a guiding question. The guiding question over. This is the guiding question. Which specific assets of S&P 500 analysis require the historical depth versus price action data? Exactly the kind of reflective prompt that makes this system educational. At the very end, it included disclaimer, educational simulation, consult professions, assume balanced data. Why it failed validation. So why did this test scale fail? The issue is formatting. The JSON block itself is perfectly structured, but notice what happens after closing brace. There is an extra explanatory sentence outside the JSON object. The validator enforces strict schema rules. All the content must contain within the JSON block. No extra text is allowed. This is not conceptual failure. In fact, the assistant demonstrated excellent reasoning. But this is a contractual failure. The system requires adherence to schema over creativity. This illustrates the tension between free form of natural language and rigid schema compliance. Failed cases like this are valuable because they show not just the assistant got wrong, but what it almost got right, and how to refine the prompt instructions so that intelligence does not break the structure. Now we can go and we will work on few of the examples. Prompt 1. I am 22, risk tolerance 4 out of 10, sustainability, focus, yes, casual style, optimize. So it's suggesting that there should be 50% of tech growth, 25 of ESG equities, 15% healthcare, 10% bonds. It is giving trade-offs. Risks are also flagged. Herding biases, climate stress, data cap. Reflection: how do climate risks shape the 10-year goals, pure returns of planet positive, legacy, and also disclaimer. Let's go for next. I will run 10,000 Monte Carlo paths. Monte Carlo simulation with 10,000 paths for the 10,000 portfolio using the parameters that I have specified in it. Giving me 1 year snapshot, the median outcome, VAR, upside, 10-year horizon. It's also giving me the key takeaways, reflections too. Now, if we come around for the testing results, we have passed 79 out of 100. Most failures were not conceptual, they were contractual. Issues like missing disclaimers, text outside the JSON blocks, or absent climate references. These are fixable with iteration. And the challenge isn't building the framework works. The challenge is closing the loop, analyzing failures, refining instructions, and rerunning. That's where engineering rigor meets design discipline. As part of the reflections, the three key lessons that emerged was: first, prompt engineering is architecture. It's about designing systems of constraints, not just clever wording. Second, iteration beats perfectionism. Running tests and refining quickly is more valuable than endless refining prompts in theory. And third, finance is incomplete without interdisciplinary. Embedding psychology, society, path, and nature creates an assistant that is not just useful but also meaningful. To conclude, the Northeastern Aladdin demonstrates that advanced finance systems can be simulated with documents, prompts, and validation, not proprietary infrastructure. Its failures are as valuable as its successes because they need to reveal the boundaries between creativity and compliance. The key lesson is simple: the barrier to AI innovation is conceptual, not technical. Scope, design, and iteration matter more than tools. Thank you.